Okay, I want to show you everything that's due on Monday, just so you'll definitely have it all put together for me. The first thing is Division of Polynomials worksheet, and it looks like this. Day 18, we did the odds on Wednesday, and then we did the evens on Friday for homework, so you should have this whole worksheet in the very front of your little packet there. Then Pascal's expansion. It's actually these 5 problems right here that you're going to complete. And I'm going to real quickly do an example of Pascal's just to make sure you remember how to do that. And I'm going to choose to do number 2 here. So x plus 2y cubed. Okay, so number 2 from, I think that's day 19. So it looks like this. X plus 2y cubed. So I'm going to briefly remind you, how do you set up Pascal's triangle? Because you need that for the coefficients that you're going to multiply together. So you start with your triangle of ones. That's just my little terminology there. And remember, you want to kind of create rows. Okay, and I'm creating a diagonal of ones. But I'm being careful to create little rows here as I go. So this would be row 0, row 1, row 2, and then row 3. And it's important because these numbers tell you the power. So we're going to be looking for the 3rd row here. Then I add together these values to fill in the spot. So 1 and 1 is 2, 1 and 2 is 3, and then I get a 3 here as well. So this is the row that I need. These are my coefficients. So I'll put those in place. So 1, 3, 3, 1. And then remember what you do is you start by raising the first term to the power of the expansion. So this would be x cubed. And then you descend, or you go down in your degree. So I have x cubed, x squared, x to the first, and then I don't have an x here. Then you work backwards with the second term starting from the right side. So 2y cubed, and use parentheses because it will keep you from making mistakes when you multiply all this out. And then I have 2y to the first. Now we want to make sure that we always raise to the exponent before we try to multiply. So I'm going to kind of chunk this out just so I don't get my terms mixed up. So 2y cubed is 8y cubed. And then 2y squared is 4y squared. So I did all the multiplication by raising to a power. Now this is already x squared, so this is not 3x both squared. Be very careful with that. 3 is your coefficient, and then x squared just came from raising this to the 2nd power. Now I have to put all this together. X cubed, and then I have a 3 times a 2, so that's a positive 6, x squared y. So I'm just kind of going along, picking up all the pieces there. Then here I have a 3 times a 4, which makes 12, and then x times y squared. So I just write it like that. And then here I have a 1 times an 8, so that's, of course, is just 8y cubed. And this is your answer. Now, if this had been a negative, the only thing that would change would be that the signs would go back and forth. So it'd start positive, then it'd be a negative, positive, and then a negative. So that's how a negative would sort of play out if you were expanding with that. So that is the assignment for day 19 right here. Okay. Then Friday we had the around the room, and we did it as a warm-up to finish it up. So everyone should have that. That's a big part of the grade there. Then on, I believe it was Tuesday, we did the rational root theorem. So I want to show you that worksheet. It was on the back of the notes. And sorry, hold on, let me find it. And the notes look like this, okay? And then, so we took notes on that, and then on the back, you were supposed to do number 1 and number 2. So I want to talk through that with you real quick. And you can kind of pause as you need to and maybe work through number 2 with me here. Okay, so all the possible rational roots, but then when we did this assignment, you didn't know how to use the calculator yet. Well, now you do know how to use the calculator, so you know there's a quicker way to do it. I want you on number 1 to test all of them using synthetic division. On number 2, I'm okay if you find them on the calculator, but then verify that they are indeed roots and then get the other roots that way. So it'll be a little bit quicker than testing all of these. The possible rational roots here are all the factors of 30, which are 1, 2, 3, because 1 times 30, 2 times 15, 3 times 10, 5 times 6, 6 times 5, and then you get your other pairs for that. Those are all the possible factors of 30 over all the possible factors of 1. So it's simply going to be all these values here. Okay, and then when you graph it on the calculator, so let's do that. So when I graph it on the calculator, just making sure y'all can see what I'm doing here, it will be x to the 4th minus x cubed minus 29x squared minus x minus 30. And then when I graph it, I know I'm kind of looking for, I'm going to set my window here. I usually just start with this, but play around with it to get what I need. So it looks like I might have a root at negative 1, 2, 3, 4, 5, which is one of our possible rational roots. And then it looks like I have one at 6 as well. So I'm going to use those, and I'm going to sort of stack them, okay? But I need to make sure when I do the synthetic division, I get a 0 here, and then I also get a 0 here. So I did indeed do that, and then I simplified down to x squared plus 1. And because my b is 0, I don't have to use a quadratic formula here. I can just solve using square roots. So I have x squared plus 1 equals 0. I subtract 1 from both sides. I take the square root. I end up with these two imaginary roots. And that is why we didn't see them on the calculator, is because they're imaginary. So that is the assignment for day 21. And then day 22 and 23, we started on Stu's packet. It's actually just a worksheet for you guys because we typed it up and put it on a worksheet for you. And we did most of that in class together, but let me show you that one. And I apologize, I didn't have it with me right there. Okay, so we did this one and we pretty much did that together. Okay, and then the homework over the weekend, you are supposed to do just the odds on the worksheet I gave you called More Practice. Okay, and I want to kind of go over one of these with you real quickly. Okay, I'm looking at number 3 here, and the reason I'm looking at number 3 is because I want to show you how it looks when you have to pair the factors of the constant with more than one factor for the lead coefficient. So it's a little bit different scenario here. So when I write all the factors of my constant, it's 1, 2, 3, and 6. All the factors of the lead coefficient 2 are just 1 and 2. But then I have to make sure to pair the 1 with the 1, the 1 with the 2. So I'm starting to get some decimal options here, which is a little bit different. So then I do the 2 with the 1, which is 2, and 2 over 2, which of course is just this same 1. Okay, I know I'm going pretty fast, so you can pause it and kind of try to take it in and make sense of it. 3 over 1 is this 3, and then 3 over 2. And then 6 over 2 is just 3, so it's right there, okay? So pause and take time to make sure you understand all those possible rational roots. Now let's graph this so you can kind of see what we're looking at. So it's 2x cubed minus 3x squared minus 4x plus 6. So I'm going to graph it and kind of see what I have. Okay, I can't really tell what's going on because it's I have a lot of extra space over here on my x's. So I'm going to go into my window and I'm going to change it to maybe -5, 5. And then same maybe for my y's, do the same thing and see what happens. So I have -5 to 5 for my x's, -5 to 5 for my y's. Now, I have a negative, something between -1 and -2, and I have something between 1 and 2. So I need to figure out if those are actually possible rational roots, or if they're imaginary. They wouldn't be imaginary, we can see them there, but they might be irrational. So I see 1, 2, 3 roots, so I know all of the 3 roots are accounted for. I just don't know whether they're rational or irrational. So what I'm going to do is go in and see if this is a root. So I think it might be the -1/2, but I'm not sure. So do second, and do calc and then value, and then do -1/2. Okay, it did not give me a 0. It is not a root at -1/2. Okay, because that would be right there anyway. So maybe it's the -3/2. So let's look at that. So second calc again, value, and -3/2, and it is also not a real rational root. So I may have a root over here. So let's see what's going on over there. So when I do second calc, and it might be a +3/2. Whoops. So second calc, and I'm going to do 3 divided by 2. Maybe it's a rational root, and it is. I do have a rational root at 3/2. So even though it looks a little strange, we would use 3/2 here in our synthetic division. So I have a degree of 3, 2, 1, and 0. So all of my terms are present. So I can start my synthetic division. So bring down your 2. Now, this is a little bit more complicated because it's 2 times 3/2, but the 2's just cancel, so I get a 3. I get 0 here. 0 times anything is 0. -4. Now, -4 times 3 is -12, divided by 2 is -6. So again, I'm verifying that 3/2 is a rational root. Then I have a quadratic, x squared minus 4, that I can continue to work with. So 2x squared minus 4. Set that equal to 0, and I'm going to solve. So I get x squared is equal to, I'd add the 4, divide by 2, and I get x squared is equal to 2. When I square root both sides, I end up with x squared is plus minus the square root of 2. So those are the two other irrational roots that I see on my graph. It's this one right here. Okay. So I have two other irrational roots on the graph. So that should help you get everything together for what you have to turn in on Monday. Have a great weekend.